All right, 8.5. Right. And graph exponential growth functions. Okay, so the next section kind of goes with it. That's why I was saying like it'll
Wait, is it scientific notion?
Huh?
Is it scientific notion?
What?
Is it scientific notion?
No, we're done with
Did
that.
you say scientific notion?
Yeah.
It's notation.
Oh, oops.
Scientific notion.
So I was like, huh?
Speak American.
The next one will be exponential decay functions. Okay, that chapter or the next section. So just be aware that these two sections are very closely related to each other.
Wait, the what?
Oh my gosh, Joey.
Sorry, I was very focusing on this.
This section will go with the next section.
Oh, okay.
Scientific notion.
There we go.
You're a leprechaun.
All right, an exponential function is a function of the form y is equal to ab to the x, where a is not equal to 0 and b is greater than 0 and b is not equal to 1. Okay, another thing about them, they are nonlinear functions. Okay, just meaning that when you graph them, they don't make a line. That's all that means. All right, so we're going to draw two tables. We're going to compare what we would do for a linear function and then talk about how we would do it for an exponential function. So we're going to have x and y, and then on the top I've got -2, -1, 0, 1, and 2. And then in the bottom, -4, -1, 2, 5, and 8.
Oh, I remember this.
Do you?
Yeah, we did this all the way like 7th grade. Oh, no, usually you do this.
Joey, are you sure that you know what you're talking
Yeah, because we're quarantined. Now I did not understand like at all.
about? I know.
I know the graph, just not remember it. Looks like
Yeah, the graph. I know.
looks like it was called from like a plant or a leaf.
All right,
The
so
stem plant? That's not that.
how do I get from here to here?
You subtract, I mean, you
Add,
add one.
you add,
Add 1. How do I get from here to here?
add.
2. Add 1.
Add 1, okay, and that's going to be the same all the way across. Okay, all the way across, I'm adding 1 everywhere. Okay, down here, how do I get from here to here? Add 3, here to here.
Add 3.
Add 3, okay, and so on, all the way across. So, okay, our initial value of our function is when x is equal to 0. What is y equal to? Okay, that gives us our y-intercept, so y would be 2. And then the amount that it changes by every time we add another x, okay, is 3. So we would have had the equation y is equal to 3x plus 2. That would have been the linear function. Okay, so we're going to do something similar to figure out how we get from point A to point B for an exponential function. So this time, gonna look similar. Alright, so x and y, -2, -1, 0, 1, and 2. And then 2/9, 2/3, 2, 6, and 18.
Whoa, fractions, no thanks. I think Joey should do all the fractions.
Alright, so the top is just like the linear one. Okay, to get from here to here, I add 1, and it's the same all the way across. Those arrows look really bad. Wow, that's embarrassing. Alright, to get from here to here,
I don't know.
how about if I said to get from here to here?
Ooh, 4.
Okay, times
Yeah.
3.
So much.
Okay, and that's what I'm going to do. If I multiply 2/9 by 3, it's going to give me 2/3. So all the way across, okay, I'm multiplying by 3. Okay, that's how I get all the way. So when I set this up, an exponential is written as y is equal to, okay, wherever x is 0, we have that number in front. So that means 2 times, and then whatever this number is that gets us from point A to point B, B to C, okay, all the way across, we write that number down, and then we write it raised to the x. Okay? Let's see. So, we're going to write a rule for number 4. So, we have x and y. And most of the time, they're going to give you -2, -1, 0, 1, 2. So that's all just staying the same. So you don't really have to look at the top every time necessarily. The bottom values they give you 1, 2, 4, 8, 16. All right, so the top, okay, it's just adding 1 every time, so I'm not going to worry about anything with that. How do I get from here to here?
1.
2.
Okay.
4.
Multiplying by 2. Okay, it's multiplying by 2 every time, all the way across. So, okay, where x is equal to 0, y is equal to 4, so it's going to be y is equal to 4 times, and then whatever this number is that you use to get from A to B, okay, which in this case is 2, and then you raise it to the x.
Wait. Where's that 4?
Because when x is equal to 0, y is equal to 4. So this is, if I were to plug back in, okay, and you'll see this in a second because we're going to kind of do the reverse of this problem in a minute. Okay, if I put in 0 for x, 2 to the 0 is what?
1.
1. So 1 times 4 is 4. And so when we put in 0, we get y is equal to 4. So that's why we write that down first.
So whatever is under 0 is blue.
The number that goes out front. And then whatever gets you from A to B, okay, and B to C, C to D, all the way across is the number that goes with the exponent on it, the x.
Are we doing the kind of problems where, like, you have to, like, you have that, but then you have to, like, I don't know.
We'll do the reverse where you're given this and you have to make the table. Yes. And we'll graph them as well. So, all right, number 6. Okay, again, we're given a table. Two, and 1/8, 1/4, 1/2, 1 and 2. So how do I get from A to B? If you don't see it doing it that way, how do I get from here to here? It's the same all the way across. Okay, by 2. Okay, what is my initial value when x is equal to 0? 1/2, so it's going to be y is equal to 1/2 times 2 to the x. All right, the next function, say to graph the function and identify its domain and range. I'm not worried about the domain and range part, but you do need to graph it. So, and you don't really need graph paper for this. This isn't something that's like a super like exact graph. It's going to be pretty like, yeah, chill. Anyways. So 10, we have y is equal to 7 to the x. Okay, and just for consistency, I always want us to go -2 to 2. So I want us to create this table here, and then we're just going to fill in the values, okay? Because pretty much any number you'd be given, you should be able to square it, which is why I say go out to the 2's. So we're going to create a table with x and y values in it. Okay, so I'm going to start with the middle one. 7 to the 0 is what? 1. So I put a 1 there. Here, let me do this in red so it's a little different. Okay. What is 7 raised to the 1? 7. 7 raised to the 2? 49. Okay. Now, once you have these numbers here, because these are negative exponents, okay, if there's something out front, okay, like how we had the 4 out here, then you need to check it. But once you put the 1 over here, this is a -1, meaning what happens to this? You have a negative exponent, okay, you move it to the bottom. So this is just 1 over 7. And then the one that's the -2 is just 1 over 49. So once you've done it once, that's all you have to do.
Oh, that's it?
Okay, now we need to graph it though.
Oh, it's not.
Okay, from -2 all the way out to 2. Okay, now a lot of times this squared value here is going to be really big. You don't have to put that value on your graph.
Thank you.
Okay, only go out to whatever this one is. Okay, if it's like insanely big, then we'll talk about it. But I'm not going to give you one that's super crazy. The book might, but I'm not going to. 4, 5, 6, 7. Okay, so at -2, it's 1 over 49, so it's literally almost touching the axis there. At -1, it's 1/7, so still pretty close, but a little higher than the other one. At 0, it's at 1. Okay, and I'm just reading these off. At -2, it's at 1/49. At -1, it's at 1/7. At 0, it's at 1. At 1, it's all the way up at 7. Okay, at 2, I'm going to ignore it just because that's so big. So what you're going to do is you're going to start here and you're going to draw your line. I say a line. You're going to draw your curve through the points, and it's just going to look like that.
Oh, wait, what if it's like a line? Or does it have to be a curve?
It's not supposed to be a line. It's supposed to be a curve. Exponentials are curves. Okay, and you have to put the arrows on the end of it. Okay, these arrows here, okay, symbolize that it keeps going because it goes on forever. Okay, in both directions. It's going to keep going all the way forever and ever. Okay, a growth function will always look like this. Okay, we're on the right side of the graph, it's pointing up. Okay, the next section will be decay functions. They will be the opposite. The left side will be pointing up. Okay, so in this section, all your graphs should look like this. It's just a matter of what these numbers are.
So it never goes down?
Let me make sure your book's not going to do that.
Decay is the left side.
There's a possibility that it could go and be upside down, but we won't get to that today. Okay. But again, that's why we plot these points, because what could happen is that this could actually flip all the way upside down.
We did actually
So
not
like
do
you see how it's like up like this right now?
Oh, I can watch.
Okay, how like it's up like this. If there's a negative, it could flip it down like this. So it's a chance, but it's going to be going all the way up or all the way down on the right hand side for growth functions.
Is the x ever different?
No, I want us to all use those values, -2 to 2. 1, it makes it easier to grade, and 2, it makes it easy to graph. Okay, so you need to have those 5 values drawn out in the table, and you need to at least graph the -2, -1, 0, and 1. Because like I said, the value for 2 is probably going to be pretty big.
What if it's like not good?
If it's not, then go ahead and put it on there. Like if this was 2 to the x instead, 2 squared is 4. That's easy to put on
What's,
there.
like, the limit?
I mean, you should know. I mean, I wouldn't do something that's bigger than like 10 probably. If you're counting by ones. I mean, I could graph this one by counting by 5s or by 10s if I wanted to. I just think it's excessive. And I would rather see here what's happening with the curve at this part, because exponentials just mean it gets really big really fast, or in the other case, really small really fast. So I would rather see this curve part here, because if I graphed this by 10s, I wouldn't even see that this point would be way down here. You know what I mean? So like it'd be really hard. I would rather see this area here than worry about a number that's 49. But if you're just ambitious and want to do it, that's fine. I'm just not going to be looking for that specifically.
Tractor? Or is there some more? What was a tractor? That's what I remember.
All right. Number 12. Y is equal to 9 to the x. So again, you're creating your table. So what happens when you put 0 in for x?
1.
Okay, 1. What about when I put 1 in?
9.
9. What about when I put 2 in?
81.
81. Okay, so then when I put -1 in, what happens?
It's 1 over 9.
Okay, 1 over 9.
1 over 81.
Huh?
1 over 81.
1 over 81. So then I can come over and draw my graph. And then just for the sake of space, I may actually count by 2s here. Just, if you do count by something other than 1s, make sure you label it pretty clearly. Okay, I didn't label anything over here because I just did it by 1s, but make sure you make a note of that. All right, so at -2, I'm at 1 over 81, so again, pretty close to the line. -1, it's at 1/9, so pretty close again. At 0, it's at 1, so make sure, it's another reason to make sure you label stuff since I counted by 2s here. Okay, it's not up at the first mark, it's halfway between the first mark. At 1, I'm at 9, so I'm up in here. Okay, 2's at 81. I'm definitely not graphing that. So then you just need to connect your dots. there's your exponential function.
So all the graphs are going to basically be the same.
Yeah. That's why I also make you give me the table. All right. All right, so 13 through 16 are decimals, and I'm not expecting you to know what 4.3 like squared is, so I'm not gonna make you do the decimal ones. We are gonna do the fraction ones because they're really not that bad, again, because it's just squaring stuff. So 18 y is equal to 7/2 raised to the x. So I've got my table. All right, so raised to the 0 is what? Okay, 1. Raised to the 1, still 7/2. Raised to the 2, 49/4. Okay, now remember what I told you. With these, all you have to do is, well, when they're a whole number, you're writing it as 1 over whatever that number is. When they're a fraction, all you do is flip them. So at -1, it's going to be 2/7. At -2, it's going to be 4/49.
How do you do
What? Oh. Okay, sometimes with this is where I'll go when I'm trying to figure out, like I said, I mean, 49/4, well, I mean, it's not that big, okay? But a lot of times what I'll do is I'll rewrite these as decimals when I go to graph them, just to make my life a little easier. So 7/2, okay, is going to be 3.5, so that way I can just kind of eyeball it. Again, it doesn't have to be perfect when you graph. I'm not looking for a perfect graph. I'm looking for that you understand the concept. I'm honestly, as long as you get the direction correct on the graph, like, because when we get decay, like I said, they'll be going the other direction. As long as you get the direction right, that's like the big thing for me if you have the numbers in the table right. That's why we spent, in case you were wondering, why we spent so much time on those exponent rules. It's because it makes a difference when you get here. Okay. Now 49/4. Okay. 48 divided by 4 is 12. So it's a little bigger than 12. So it's like 12 and 1 left over. So 12 1/4 or 12.25. Okay, approximately. Okay, when it's these fractions like this, I don't care. It's just close to 0. Okay. So I'm probably not even going to, I don't know why I did that. You don't need that much space on the bottom. I'm probably not even going to graph this 12.25. I'm probably only going to graph the 3.5. So -2, -1, 0, 1, and 2. And I'm just going to go up to like 4. So at -2, it's at 4/49, which, again, they're just going to all be close to 0. -1, still pretty close to 0. At 0, it's at 1. And at 1, it's at 3/2. And you're just connecting the dots. It's like those connect the dot puzzles from when you were little. Actually, somebody, because they know how much I like math and stuff, somebody, like the adult coloring books, somebody got me an adult dot to dot that the numbers go from like 0 to 500.
Why?
They make really cool pictures though.
Why?
I love it. It's so much fun.
I'm terrible at drawing lines.
For some reason, when I see like small circles, it makes me super dizzy, so I can't like look at that kind of stuff.
I cannot draw a straight line.
That makes sense.
I kind of want to fucking
So
Oh, I got
there's
you,
no
Chris,
point
I
in me
got
doing
you.
it.
I
if it
got
doesn't
you.
even work.
Your birthday next year? Oh, I
yeah,
got you.
give me one of those.
Remind me a year from now.
All right, well, we're going to do one more and then we'll be done for today. Okay, we'll finish up this section tomorrow. All right, so we have y is equal to 5/4 raised to the x.
Something better than connected on.
Stop, Chris wants to connect dots on me. Get him a computer.
Joey's right though. You could probably get some.
Okay, here.
All right, at 0, what do we have?
1 for 0, 5/4 for 1.
And for 2,
25/12, 16.
25/16.
And then you flip those two for those.
So 4/5 and 16/25. Okay, with one like this, I probably would just leave it. I know this is about a little bigger than 1, and then this one is like 1.5-ish. So I'm going to make my graph super obnoxious with this one because they're so like small.
Stop looking at me, Chris.
So I'm going to literally put 1 like all the way up there. So at -2, it's at 16/25, still really low. At -1, I'm at 4/5. Okay, which is obviously a little farther up. At 0, I'm at 1. And then, let's see, throw 2 way up here somewhere. So at 1, I'm at a little bigger than 1. And at 2, since that one's like literally just like 1.5, I'll go ahead and put it. I need to bring this point down a little bit. It's not really supposed to be a straight line. My dots just aren't in a, yeah, hold on. I'm going to fix it. These dots just aren't right.
It's okay. I'll see it.
It's
Yeah,
close
Joey
enough.
can know the difference.
Okay. I mean, and they will be a little steeper. Okay, again, this is why you got to have your units kind of, or your, well, anyways. That's why I said I don't really care so much what the graph looks like. It probably would have been better if I actually made it to scale instead of obnoxious, but I decided I was going to be obnoxious, so whatever.
Just pretend like my graphs for the homework look right because they don't. But it's okay.
It's going
All right.
under the graph.
I'm going to go ahead and give you these. If you want to start on them, you can. But tomorrow we're going to do more of these that are adding another step. So we're adding a number in front. So like adding a 2 out front here and what happens.
Is there a task for it yet?
No, because I'll wait and do one after we're done tomorrow.
Okay.
Yeah. Okay, so that is your problems there.
Finish the whole